Hello, beta. Good evening.
Good evening, sir.
So, how are we today?
All good, sir.
Okay, good. Okay, so most of the people have joined in. Now, yesterday we did some concepts of celestial navigation based on rational horizon diagram. We basically saw the circumpolar bodies and we saw the concept of twilight. So, today we will be going ahead into our next topic, that is stars suitable for observation. Now, this topic is a little tricky and complicated. What makes it tricky is that this topic is not well covered in any of the books. Even if it is covered somewhere, the questions which are there, they either are solved in a wrong way or the answers are not matching, and they are also at not the same level of the question which are asked in the exams. So this becomes a little tricky, complicated thing. So we will go into this topic step by step, slowly, one by one. We will divide this question into sub parts. Total 5 different parts. I have divided it into 5 parts. We will start off with the basic one, most basic one, and then go to the next level, then the next level, and ultimately completing all 5. So before we go into this topic, we have to cover 2 more basic topics. These are one, the topic of stellar magnitude, which is a scale of brightness of celestial bodies. We need to be familiar with what is the stellar magnitude, what are first magnitude stars, what are second magnitude stars. And second thing which we need to be clear and comfortable with is the stars information table which is given in the almanac. So keep the nautical almanacs in front of you. We will first go into magnitude and stars table, and once we are comfortable with these, then we go into star suitable for sight. In this topic, we will be using the concept of twilight, which we did yesterday. We will also be using the concept of circumpolar bodies towards the end. Okay, so with that said, we are ready to now go into the topic. Ready, beta? Chale?
Yes, sir.
Okay, great. Let's go, beta. Let me put out the presentation. In this presentation, we are going to discuss the concept and topic of stars suitable for observation. Now, this particular method, stars suitable for observation, is used to ascertain or find out which stars will be suitable at the time of twilight for a particular observer if he wants to use a specific method of sight or a specific method of observation, like meridian passage, marpass or latitude by meridian altitude, or X meridian. So basically this means that if a observer wants to take a star sight at the time of twilight, Twilight is the only time when a star site can be taken. So he wants to take a star site, but he wants to use a specific method. He wants to use a particular star for meridian passage or for a X meridian site. Now, how to find out of so many stars which are visible to us in the sky, which of them are suitable for the Marpas observation or for the X meridian observation? That is the meaning of the topic, stars suitable for observation. Now, before we go into this topic, we need to understand a few basic concepts to familiarize us with the method and procedure which we use to determine which stars are suitable for meridian passage or X meridian. Now we understand that only those stars will be suitable for a Marpas observation which cross the observer's meridian during the twilight time. Meridian passage site is taken at the time of the celestial body crossing the observer's meridian. And if we want to use a particular star for X meridian site, we are aware that that particular star should be within the X meridian limit. So we need to check the X meridian limit for the observer for that particular body, and we need to make sure that the particular star is within that X meridian limit to be suitable for a X meridian observation. Now, the basic topics which we need to understand before we jump into this topic are number one, the concept of stellar magnitude, and number two, the concept of twilight. So we are going to understand these concepts one by one. Let's first go into the concept of stellar magnitude. Stellar magnitude is a scale used for specifying the apparent brightness of a star as observed from the Earth. The magnitude number decreases as the apparent brightness of a star increases. You can see this diagram showing some specific celestial objects, celestial bodies, and also their stellar magnitude. You can see the brightest object in the sky which we have is the Sun, and it has a stellar magnitude of minus 26.8. Now, as I told you earlier, the magnitude number decreases as the apparent brightness increases. So the celestial body having maximum brightness is the Sun, and it has the minimum magnitude number. The magnitude number of the Sun is minus 26.8. Now, after the Sun, we have the Moon, the second most bright body in the sky, and the stellar magnitude of the Moon is minus 12.5. Then after the Moon, we have the planet Venus. When it is at its brightest, it has a stellar magnitude of minus 4.4. Then we have star Sirius having a stellar magnitude of minus 1.5. Then Alpha Centauri, the nearest star to us after the Sun, having a stellar magnitude of 0.0. Then Betelgeuse 0.8, Polaris 2.5. Now, the limit of the naked eye is stellar magnitude 6.0. These stars with magnitude 6.0, very, very faint stars, barely visible to the naked eye, are the 6.0 magnitude star. They are also called as sixth magnitude star. The brightest of the stars which we have, like Betelgeuse, Alpha Centauri, Sirius, they are called as the first magnitude star. So faint stars barely visible to the naked eye, sixth magnitude star, and the brightest of the stars coming under the first magnitude stars. Now, if you go little more further, if you use a binocular to observe the sky, you would be able to see the stars having a stellar magnitude up to 10. If you have a 1 meter telescope, it can help you to see the stars up to a stellar magnitude of 19. Then another important telescope which we have, Hale telescope, can see the objects having a stellar magnitude of 27. And the most powerful telescope which we have, the Hubble telescope and the Keck telescope, they can help you to see the stars, celestial object with a stellar magnitude number 30. So a diagram giving us a comparison of the brightness as well as the stellar magnitude of different celestial bodies. Now, a first magnitude star is 100 times brighter than a sixth magnitude star. Any doubts up to here, beta?
So from Sun till Polaris, all first magnitude stars. Sir, correct?
Oh, not Polaris, beta. Betelgeuse.
Betelgeuse. Yes, sir.
Okay, I'll tell you how they are categorized.
Okay, sir.
Okay. We can also calculate, if we have two celestial bodies, their stellar magnitude known to us, we can calculate how many times a particular celestial body appears brighter than the other celestial body. We have a formula which can be used to calculate the relative brightness, and that formula is relative brightness of a body compared to another celestial body is equal to 2.51 raised to power x. Now, what is x in this formula? X is the difference between the magnitudes of two bodies which are being compared. So, if you are given two celestial bodies, their stellar magnitudes are known. You can find out the difference between their stellar magnitudes. 2.51 raised to power that difference gives you how many times a particular body is brighter than the other. Any doubts, beta? Very good. Now we have seen the stellar magnitude of the stars. We know that the faintest of the stars are of magnitude 6.0 and the brightest of the stars are magnitude 1 star. Now these stars are categorized basis their brightness. We have put them into categories. Now what are these categories? All the stars having their magnitude less than or equal to 1.0. That also includes the star in the negative stellar magnitude range. So all the stars having magnitude less than or equal to 1.0 are called as first magnitude stars. This is a group of the brightest possible stars in the sky, and they are the most preferred stars for the purpose of sight taking or for the purpose of observation. We always prefer to have a first magnitude star for our sight taking purpose. They are the easiest to spot in the sky, being the brightest. Now, stars having magnitude greater than 1.0 and less than equal to 2.0 are called as second magnitude stars. In case you are not able to find a suitable first magnitude star for the purpose of sight taking, you can also choose and pick up a second magnitude star. They are also bright enough to be used easily for the conveniently for the observation. Now, after this, stars having magnitude greater than 2.0 and less than equal to 3.0, they fall under the category of third magnitude stars, and so on. 3.0 stars having magnitude greater than 3.0, less than equal to 4.0, fourth magnitude. Stars having their stellar magnitude greater than 4.0, less than equal to 5.0, fifth magnitude, and so on. Now, why are these categories important? Because in the questions, they sometimes ask us to find out the first and second magnitude stars which are suitable for a particular observation. So in that case, we check their magnitudes from the almanac, and whichever magnitudes fall under our required category, we pick up those stars and write them as our answer. Any doubts, beta? Very good. Now, going further, we need to be familiar with the stars information table given on page number 268 of the 1992 almanac. Let's have a look at that table. We have the left hand side page of the table. This is page number 268 of the almanac. And now you can see on the right side is the right hand side page of the stars table, that is page number 269. Now this table gives us the required information about the stars. The first column which you see gives us the magnitude number of each of the star. The second column gives us the name and number of the star. After this, you see the next column of the table gives us the SHA and declination of the stars from January to June. For the first 6 months of the year, the SHA and declination is given on the left hand side page. You have the SHA given first, later on followed by the declination of the star. Now we are aware that the SHA and declination of the star does not change much. There is a very minute change in the SHA and declination of the stars. They can be practically assumed to be fixed bodies on the celestial sphere. So that's why you see in this particular table, the degree values of SHA is mentioned in the beginning, and the minutes are mentioned under each and every month. Now the change in SHA, what happens is happening only in the minutes. The degrees usually do not change. So under every respective column of the month, you see the minutes value is given. So you pick up the degree value from the first column, and then you pick up the minutes value from whichever month you require the value for. The same is done with the declination. You see the degree value is given initially in the first column, followed by the minutes value for each and every month. And you can see here that the value changes by a certain minutes every month. The change is very, very gradual and slow and not very significant. Now on the right side of the page, we have the SHA and declination of the stars given from July to December. So the right side page gives us the required information for the last 6 months of the year, July to December. You have the SHA and then followed by the declination. Again, the same format is used. Degrees are given in the beginning and number of minutes are shown under each and every month. Now the stars are listed in this table as per increasing order of their SHA, sidereal hour angle. You can see the stars starting in the table from 000 SHA, going up to 360-degree SHA. So the first stars which you see is 5-degree SHA, the next one 13, 14, 15, and so on. So if you want to identify or pick up a star from its SHA value, this table is very convenient to use. You can enter into the SHA value column, and whichever SHA value you require, you can identify that particular star from this table. Now the left side page of the table gives us the Latin names of the stars. The names which are mentioned here in this particular column are the Latin names of the stars, along with the SHA and declination from January to June. Whereas the right side page which we see gives us the English names of the same stars. And also, as we discussed just now, it gives us the SHA and declination of the star from the month of July to the month of December. So important thing to remember here is whether you go to a particular star on the left hand side page or you go to that particular star on the right hand side page, it is the same star mentioned. Only thing is the names given on the left side page are Latin names and the names given on the right hand side page are English names. To give you an example, pay your attention to the number 2 star which we have on our list. On the left hand side page you see the number 2 star which we have is Alpha Pegasi, whereas if you go to the right hand side page of the table, the same star is mentioned as Markab. So on the left hand side, Alpha Pegasi, on the right hand side, Markab represents the same star. Alpha Pegasi is its Latin name and Markab is its English names. Now, as far as our exams are concerned, we always use the English names of the star. So whenever you are required to identify and list down the stars, you will be picking up the English names, irrespective of the month of the year, whether it is January or June or July or December, any month of the year, you will be picking up the names in English. That means the name from the right hand side page of the table. So if you are picking up the second star, even for the month of January, the star will be named as Markab and not as Alpha Pegasi. Any doubts in the table, Peter?
Sir, this name and number, the number one is which one, sir? This 57, 56, 55. What is that, sir?
Okay, that's not required for our purpose, but that number is a certain number given to that particular star. Actually, there is a table in the Nautical Almanac where some selected stars are listed. Now, that table unfortunately is not there in the selected pages of your 1992 Almanac which you have. It is not there. But if you see the Principles of Navigation book, there are some pages of 1976 Almanac there. There you can find that page. So there are total 57 selected stars which are very easy to identify in the sky. They are listed. So this number basically refers to that list. We
Okay.
don't need this number for our purpose.
Okay, sir. Thank you.
Okay. Great, beta. Very good. So this is what is required for going into the star suitable questions. Now we are familiar with the stars table information, how to pick up the information from the table. We know that. We are also familiar with the concept of twilight and as well as the stellar magnitude. With these, now we are ready to go into star suitable for sight questions. So I'm closing down the presentation now.
सर ये इंग्लिश नेम्स में few names are symbols are also given सर, जैसे थीटा थीटा भी दिया हुआ सर.
आपको आंसर में सिंबल्स भी लिखने हैं बेटा, because two stars may have the same name, the only difference may be in the symbols. So write the symbol as well as the name.
Okay, sir.
Okay. Okay, great. Now I'm showing you these examples of stars suitable through a video. Okay, so we will see these examples one by one. As I told you, I have divided them into 5 types. So we will start with the most basic one, that is type 1, then move on to type 2, type 3, type 4, and type 5. Okay. Also, I had told you about the X meridian tables when we were solving the sites. Remember beta, there are 4 X meridian table. We use number 1 and number 4 to get the X meridian limit. याद है? भूल तो नहीं गए?
Yes, sir.
Okay, great. We will be using that in the questions. So let's go beta. Let me take you to the video.
The entire process of star identification based on various needs has been divided into few categories, and we shall see each one of them through some examples.
Beta, is the audio video working well?
Yes, sir. Clear.
Okay, great.
The first one shall be, we shall try and find out the stars which shall be within a certain hour angle of the observer's meridian at a given time. Now, on 15th June 1992, in position 20 degrees north, 075 degrees east, which all stars and planets of first and second magnitude will be within 15 degrees of observer's meridian at the end of civil twilight. We shall assume in such cases an imaginary star on the observer's meridian and determine the SHA of that imaginary star. We know that when a body is on the observer's meridian, then its LHA is equal to 000 degrees or 360 degrees. We also know that LHA star is equal to LHA Aries plus SHA of the star. LHA Aries in turn is equal to GHA Aries plus minus observer's longitude. Longitude east, GHA least, longitude west, GHA best. GHA Aries can be obtained from nautical almanac against GMT. Now, if the time in question is given in GMT, it can be directly used. If some other time is given, that needs to be suitably converted to GMT.
Beta, any doubt in the first 2 points?
Sir, in the first equation, it is equal to 360 degree only, no, sir. Zero will not come, right?
Beta, 0 and 360 are interchangeable. You can keep it equal to 0 or you can keep it equal to 360. Both will give you the same answer.
Okay, sir.
Okay. Okay, great.
If the time at all is not mentioned in the question and it is only morning or evening, then for AM cases, we shall use the starting time of the nautical twilight. Please remember, all the twilights begin at different timings in the morning and they all end on sunrise. So we take the time when the nautical twilight begins in the morning. If it happens to be a case of evening, then all twilights will begin on sunset and end at different times, and we shall use the time when the civil twilight comes to an end.
So beta, can you tell me now why for AM we are using nautical twilight starting time and for PM we are using civil twilight ending time? Why is it so?
Sir,
Go ahead, beta.
So below nautical twilight, so horizon is not clear, so we'll not able to take observation. But also when it goes above civil, we will not. So horizon is very clear, so we will not be able to bring celestial.
Sir,
Okay,
in the
great.
morning, sir, in the morning when nautical twilight starts, that time only we can see the stars, and in the evening we can see the stars till the civil twilight ending time.
Very good, beta. So basically, the suitable period for taking sight starts in the
Yes, sir.
morning when the nautical twilight starts, and in the evening, the suitable period starts when the civil twilight ends. So you see, the fundamental of twilight is used here.
Yes, sir.
Okay, great.
The range of SHA acceptable or for which in which we'll have to find the stars shall then be calculated by adding and subtracting the range of R angle to the SHA of the star on the observer's meridian. Stars in that range of SHA can easily be then identified for the required magnitude from the star information pages in the nautical almanac.
Okay, now we will see all these steps in detail, beta, when we solve the question. All these steps will be followed one by one, so you'll understand there.
Let us now apply the listed step to this question. We need to find out all the stars and planets of first and second magnitude falling within 15 degrees of observer's meridian at the end of civil twilight on 15th June 1992, and the position of the observer is given here in latitude and longitude. Now, to begin with, please note that AM or PM is not stated in the question. It may be stated, may not be stated. But in this case, since it's end of the twilight that is in question, so the twilights end at different timings in the evening. So by default, it becomes a PM question. Had it been beginning of the twilight, then it would have become a AM question.
So did you understand that, beta?
Yes, sir.
Very good, beta. Great.
So now we go to the daily page of the Nautical Almanac for 15th June. For 20 degrees north lat, we pick up the civil twilight time in the evening. And we all know this time shall be LMT. So the LMT of civil twilight in the evening would be 15th day, 19 hours, 05 minutes and 00 seconds. To this, we shall apply LIT to get GMT. Longitude is east, so GMT is least. So therefore, we subtract this LIT and we get GMT as 15th day, 14 hours, 5 minutes and 00 seconds.
Any doubt up to here, beta? Calculation of GMT? Very good.
From the daily pages of the Nautical Almanac, we extract GHA Aries for this GMT. Now GHA Aries for 15th day, 14 hours is on the screen. To this, we add the increment for 5 minutes, 0 seconds, and this gives us the GHA Aries. To this, we apply the observer's longitude, that is 75 degrees east, longitude east, GHA least. So we add to get the LHA Aries. So the LHA Aries is 190 degrees, 21.4 minutes. Now using this LHA Aries, we calculate the SHA of an imaginary star, which is on observer's meridian. And we know that if the star is on observer's meridian, its LHA is 360. and it's equal to LHA Aries plus SHA star. Using the value of this calculated LHA Aries, we get the SHA of this imaginary star to be 169 degrees 38.6 minutes, and this star is assumed to be on observer's meridian.
Okay, beta. So we have obtained the SHA of a imaginary star on the observer meridian. Any doubts up to here?
The LHA star, where did he get, sir?
Okay. Beta, this star is a imaginary star and it is on the observer's meridian, right?
Yes, sir.
Any body when it is on our meridian, its LHA has to be 360. That's why we have kept the LHA of the star equal to 360.
Okay, sir.
Sir, where we get the LMT, sir? That's why I'm looking on the nocturnal almanac, sir.
Okay. Beta, go on the date 15th June and look for end of civil twilight in the PM. The latitude is 20 degrees north. So have a look there. Did you get the time, beta? Under civil?
Yes, yes, sir. Yes. I got it.
Okay, great.
Now we have to find all the stars which lie within 15 degrees of observer's meridian. That means 15 degrees of this SHA. So by subtracting 15 degrees from here and adding 15 degrees to this, we find out the applicable SHA range. SHA range within 15 degrees of observer's meridian would be 154 degrees 38.6 minutes to 184 degrees 38.6 minutes. That means all the stars and planets with within this SHA range shall be within 15 degrees of observer's meridian.
Okay, any doubts up to here, beta?
Sir, the questions will be always asked on the observer's meridian like this, sir, or it can vary?
It will always be based on the observer meridian, beta. Our angle can change. They can ask 15 degrees, 20 degrees, 25 degrees, but the reference will always be observer meridian.
Okay, sir. So then that equation will be always the same. Only the LHA Aries we need to find.
Yes, that's right.
Okay, sir.
Okay, great. So the SHA of our meridian was 169, 38.6. Now we have found out the two SHA limits basically by adding 15 to this value and subtracting 15 from this value. Now we will find all the stars within this range. So we will go to the stars table and find the stars.
Now we go to the daily pages. Sorry, we go to the table for stars. Now, if we go to the table for stars in the nautical almanac, we know that this information is tabulated in the ascending order of the SHA. We identify this range that we have calculated, and we see that this is the range which is in question here. Now, in this range, we find out the stars of first and second magnitude. Magnitude is in the first column. So we identify there is one star here of magnitude 1.2. Then there are two stars out here, one of 1.7 magnitude, another of 1.5. Then two more here, 1.6 and 1.1 magnitude respectively. In this range, we find these are the only 5 stars which belong to first and second magnitude. So these are the 5 stars. Now these are the Latin names of these stars. On the opposite page, we can have their English names. Their SHA can be picked up from here for the month of June, and so is their declination. And we can tabulate these stars then. Stars of first and second magnitude within 15 degrees of our angle of the observer's meridian. And these stars with English names are then Spica, Elliot, Mimosa, Gacrux, and Acrux, together with their SHAs and declination.
Okay, beta. Now, beta, you can check this. You can go to the stars information table, look for the stars in this range, and see that you are getting all these 5 stars. If there's any doubt, let me know, beta.
Sir, this declination, nothing to do with this declination, north or south.
As far as this question is concerned, it is not required, but later on, beta, when we go to other types of question, declination will be needed.
Understood.
Yes, beta, you have to write the full table. Only thing which you can omit is the star number. Star number is not mandatory, it can be removed, but the remaining item have to be included. Even if they have asked you the names of the stars, you have to include the magnitude, the SHA, and the declination.
Can you repeat, sir, one more SHA range with the 15 degrees? I'm just confused from here.
Okay, beta, okay. Beta, this SHA which we calculated earlier, 169.38.6, is the
Yes, sir.
SHA of our meridian, observer's meridian, right?
Yes.
We wanted the stars within 15 degrees of the meridian. So what we did was, to this value of 169, we added 15, we got 184, and we
Yes, sir.
subtracted 15, we got 154. And
Yes.
this becomes our range to pick up the stars from the table.
Yes, sir. Yes, sir. Thank you, sir.
Okay. Clear, beta? Understood up to here?
Yes, sir.
Very good.
Sir, if for the question we have given only at observer's meridian, then we need to check only with that SHA of star.
Yeah, they will ask always these reference will be the observer meridian. So that's how you need to check.
If they're not giving 15 degrees, if they're not giving 15 degrees, sir, they're saying only at observer's meridian. Without any degrees, only
Okay.
observer's meridian.
So you mean to say that they have not mentioned within how many degrees the stars are to be found?
Yes, sir, that's right. They're saying
Okay.
only at the observer's meridian.
Okay. The question will not make sense. So they will have to give a specific range of the angle here, because without the angle, the question becomes irrelevant because there can be infinite number of stars. Okay. But later on, maybe you are confusing it with X meridian questions. When we go to the X meridian type questions, I will tell you if this R angle is not given, what is to be done. Okay, beta?
Okay, sir.
Okay, all right. Let's go ahead.
Now for this planets, we go to the daily page of the Nautical Almanac for 15th June. On the left side, right bottom corner, we have the information for the planets. We see if any of the 4 planets listed there have their SHA in this range. We find that none of the 4 planets have the SHA falling in this range. Therefore, there are no planets with SHA in the given range or within 15 degrees of observer's meridian as required by this question.
So you can check and confirm the planets also, beta. For that, you need to go to the daily page and see the planets.
Sir, I didn't get, sir. Can you repeat again, sir, this?
Okay, beta. Okay. You have a almanac with you?
Yes, sir.
Go to 15th June 92, beta.
15th June, yes, sir.
On the planets page, come to the bottom of the page and go to the right corner.
Yes, sir.
Can you see the SHA of the 4 planets?
Yes, sir. Venus, Mars, Jupiter, Saturn.
Yes. Check if anything is falling between 154 and 184.
No, nothing, sir.
Exactly. That is the answer for this question, beta.
Okay, sir. There are no planets for this observation.
Yes, that's right. If you find something there, then you will mention it here in your answer.
Okay, sir.
Sir, if they don't particularly mention.
we can get in this.
One by one, beta.
Sir, only SHA we can get for the planets in this. Declination will not be there.
We can find the declination also. I will tell you, in case you find a planet there, then you can find the declination. See, you have the time. GMT
Yes,
is 15th day, 14 hours, 05 minutes. So for
Yes,
this GMT time, you can go to the declination column of that particular planet and you can pick up the declination also.
Okay, sir. Thank you.
Next out, beta.
So in question, if they don't mention about this planet or planets also, then also we have to check for planets.
No, if it is not mentioned, no need to check then. Okay, great. Very good, beta. Let's move ahead.
Sir, the declination has to be right comparing with only magnitude, no, sir? Declination.
Ask again, beta. Declination.
Sir, from where we have to take the declination, sir?
The declination of planet or stars?
Star, sir, star.
Beta, it is given in the same table, na? Table on page number 270. The first thing which is given is SHA, and after that you see the declination is also given.
Okay, sir, thank you.
Okay, good. Let's move ahead.
So we have only these 5 stars and no planet. I hope this question is well understood. If not, please pause the video, go back by 5 minutes and revisit this particular part before moving with the other type of questions, because this will form the basis of practically all the questions. We just learned to make a list of stars and planets which meet the requirement of given magnitude and which also lie within the given range of observer's meridian. Now, all these stars that we identified may be visible to the observer, may not be visible, may be suitable for taking sights, may not be suitable. So now next we'll try and assess their visibility criteria and also their suitability for taking sights. On 15th June 1992, in position 20 degrees north, 75 degrees east, which all stars and planets of first and second magnitude within 15 degrees of observer's meridian at the end of civil twilight will be visible to the observer and suitable for taking sight. I'm sure you'll agree with me that first step shall be to make a comprehensive list of all stars and planets which meet the given requirement of magnitude and hour angle. Now, to assess visibility, we know that the body must be above the observer's rational horizon. We also know that for a body to be above the rational horizon, for whatever period of the day it may be, A, latitude of the observer and declination of the body, if they are same names, yes, body would definitely be coming above the horizon for some part of the day. Or if they have opposite names, then the body shall be above the rational horizon only if the sum of latitude and declination is less than 90 degrees. Now, both these things can be summed up in one condition, wherein we say we find out the L difference D, difference between latitude and declination, and if the difference is less than 90 degrees, the body shall be visible. What do we mean by L difference D here? Please note, it means we are talking of algebraic difference between latitude and declination. And algebraic difference means that if they are same names, you subtract. And if they are opposite names, you add. And if the algebraic difference is less than 90 degrees, the body shall be above the rational horizon and hence visible.
Okay, beta. Now this is the important thing to note, beta, in these questions. To find whether a body will be above the horizon or not, you have to find the L difference D. If the L difference D is less than 90, body will be above the horizon and it will be visible to you. If the difference L difference D is not less than 90, it has gone greater than 90, body will not be visible. Clear, beta? Okay, great. Let's use
सर
this in the
इसका
answer. बोलो
ये
बोलो
ये
बेटा.
वाला ये वाला वीडियो मिल सकता है सर?
बेटा ये फ्रीली अवेलेबल नहीं है. यू कैन टेक द स्क्रीनशॉट ऑफ द क्वेश्चन, और ये जितनी चीज़ें आप अभी देख रहे हो जो लिखी हुई हैं, ये मैं आपको नोट्स में भेजने वाला हूँ. सो यू विल गेट द नोट्स.
ओके सर.
ओके.
So now we can close out this question. First, we have the comprehensive list of all stars and planets meeting the magnitude and hour angle requirement, which I'm sure all of us would agree is the same as the result of question number 1. So we pick up the result of stars from earlier working and now assess whether they are going to be visible or not. These are the 5 stars which meet the requirement of magnitude and the hour angle as far as this question is concerned. Now to assess visibility, we have just learned we have to get L difference D. So we insert one more column here for observer's latitude, and observer's latitude is 20 degrees north. Now we have to find L difference D. Before we show it up, just to reiterate, L difference D means algebraic difference. Same names subtract, opposite names add. And now we have L difference D showing up here. Opposite names add, same names subtract, and we have L difference D for all the 5 stars in this column.
Okay, beta, you can check the L difference D. Any doubts coming, let me know.
So more than 90 या more than 90 तो होगा ही नहीं ना सर?
नहीं बेटा, हो सकता है, बिल्कुल हो सकता है. अगर यही लैटिट्यूड 20 डिग्रीज की जगह पे 30 डिग्रीज नॉर्थ होता, तो जो लास्ट वाला स्टार है बेटा 63 साउथ एंड 30 नॉर्थ, इट विल बिकम 93 डिग्रीज एल डिफरेंस डी.
But the requirement is L difference D should be less than 90.
That is the requirement for visibility, na? It is not necessary that all the stars will be visible to all the observers.
Yes sir.
Okay. Fortunately, in this case, no one is going outside 90, so all are visible, fortunately. But in some other questions, some may not be visible.
Yes sir.
Okay, beta. Great.
Now, for the star to be visible, this L difference D shall be less than 90 degrees. And we see that for all the 5 stars, for all the 5 cases here, L difference D is less than 90. Therefore, all these 5 stars shall be visible to the observer.
Clear up to here, beta? Any doubts?
So then why in this previous slide it is given body declination and observer's latitude should be same name?
No, beta. No. They are not saying that the body's declination and latitude should be of the same name. They were simply telling you what is the meaning of L difference D. Okay. If the body's declination and latitude are of the same name, L difference D will always be less than 90, so body will always be visible. Okay. You can conveniently forget about that, whether LD are of the same name or of the opposite name. You can just find out the L difference D and it will take care of both the conditions.
Okay, sir.
Okay, beta. Great. So part A is done. All the stars are visible. Let us now see how to check which stars are suitable for sight. For that, we have a different criteria. Let's see.
Now, yes, they are visible to the observer. Are they suitable for taking sight or not? For a star to be suitable for sight, obviously it has to be above the horizon and visible, otherwise sight cannot be taken. And 2, there should be some minimum altitude, and we have put a cap of 10 degrees. So it must have altitude of more than 10 degrees. Now for if the altitude has to be more than 10 degrees, this L difference D has to be less than 80.
So beta, this is the criteria for suitability for sight. L difference T should be less than 80 degrees. This basically ensures that the altitude of the star is more than 10 degrees.
So to assess the suitability for sight, we can make one more column and see in which all cases L difference T is less than 80. And we see that for first 4 stars, they are all suitable for taking sight. The last, that is Ecrux, though it is visible, but it's too low and is not suitable for sight. So I hope you will remember this requirement to assess the suitability for taking sight and also the conditions required for a star or celestial body to be visible to an observer.
Okay, beta. So these conditions need to be memorized. And any doubts in this question now?
L minus D should be always 10 degree to 80 degree, then it is suitable for sight. Is it correct, sir?
No, beta, not L minus D. It is L difference D.
Yes, L difference D should be within 10 degree to 18 degree, then it is suitable for.
No. Even if L difference D is 0 degrees, it will be suitable. That 10 degrees is basically the altitude of the body. Altitude has to be above 10 degrees to take a sight, and this is ensured by keeping L difference D less than 80. Even if L difference D is 5, still you can take a sight.
So altitude where it's given, sir?
So it should be less than 80 always.
Yes, it should be less than 80 degrees. That's all. There is no minimum criteria.
So the 10 degree we don't need to care about.
No, you don't need to care about. L difference T less than 80 takes care of the 10 degree altitude.
Okay, sir.
Is there any specific reason that this low altitude, why we should not take the...
Okay, beta. You have the almanac with you?
Yes, sir.
Okay, just open the first page, beta. Open the first page, page 1.
Yes, sir.
Can you see the total correction table for sun and stars and planets?
Yes, sir.
See what is the altitude where it is starting.
Got it, sir.
Got the answer?
Yes, sir.
Okay.
Thank you, sir.
Okay, beta. All right. Any more
So
doubts
for
up to
this,
here?
sir, for this altitude to be above 10 degree, then where will we find altitude of these stars?
You cannot find the altitude of these stars. What you can find is L difference D, and if L difference D is less than 80, this ensures that the altitude is more than 10 degrees.
Okay, sir.
Okay. ग्रेट बेटा चलें बेटा थर्ड टाइप पे okay let's go. The third type is little heavy and complicated, so let's move to type 3.
Another type of question that is asked in the exam is to figure out or find the stars and planets which are suitable for X meridian observations. On 15th June 1992, in position 20 degrees north, 75 degrees east, which all stars and planets of first and second magnitude within 15 degrees of observer's meridian at the end of civil twilight will be suitable for X meridian observation.
So this is type 3 now, beta. Suitability for X meridian.
I'm sure you can see that the first part of the question is same as has been solved earlier. It's only that now we have to figure out as to which of those stars shall be suitable for X meridian observation. We know every visible star or planet need not be suitable for X meridian observation. To check if a star is suitable for X meridian observation, we need to obtain R angle P, which is the difference in the SHA of the star or the SHA of the planet in question and the SHA of an imaginary star on the observer's meridian. We had already learned how to calculate the SHA of an imaginary star on observer's meridian by equating the LHA to 360. So P is the difference between the SHA of this imaginary star on observer's meridian and the SHA of the star or SHA of the planet in question. Then we obtain the time to Marpas, the body is yet to cross the meridian, or the time from Marpas or since Marpas if the body has already crossed the meridian. And how do we get this time? We get this time by dividing this R angle P by 15 degrees 02.5 minutes. This will come in hours. We multiply by 60 to get this time in minutes. What is this 15 degrees 02.5 minutes? It's the rate of change of R angle for stars and planets. What is this rate for Sun? We know the rate of change of R angle for Sun is 15 degrees per hour, and it's 15 degrees 02.5 minutes for stars and planets. Then we use any of the nautical tables, and from there we find X meridian limits applicable to this case, which will depend on the observer's latitude and the declination of the body. So we get the X meridian limits from nautical tables. If the time to Marpas or time from Marpas calculated above is within the X meridian limits obtained from the nautical tables, then the star is suitable for X meridian observation. Otherwise, it is not suitable for X meridian observation.
Okay, so we will be following these steps in the question beta. This is what we'll be doing. Any doubts coming up to here? Okay, let's see the application in the question.
One of the X meridian limit table is as shown here on the screen, wherein you can use them with declination of the body and the observer's latitude, different tables for same and contrary names. However, you are likely to have different methods of obtaining X meridian limits based on the nautical tables that you use. So please familiarize with the process of obtaining X meridian limits from the nautical tables that you use.
Screen hang ho gaya hai?
Can you see the X meridian limit table beta on the screen?
Yes, sir.
Yes, sir.
Okay, all right. Now we are not using this one. This is basically Burton's table. We are using Norrie's table beta. Remember I showed you those table 1 and table 4. We will be using those tables to get the X meridian limit.
Each nautical table may have slight difference in the process and also in the values, because these values are approximate values. So there will be also a slight variance in the values, which is insignificant. You can go by the values that you get from your tables. Now we are in a position to close out this question. On 15th June 1992, in position 20 degrees north, 75 degrees east, which all stars and planets of first and second magnitude within 15 degrees of observer's meridian at the end of civil twilight will be suitable for X meridian observation. I'm sure we'll agree that first part of making a comprehensive list of stars meeting the magnitude and R angle requirement we have already done. It's the same question as the earlier ones. So we'll bring forward the same list that we made in the earlier questions. We know these are the 5 stars which meet the requirements of magnitude and the R angle. Of these, Acrux is not suitable because of its low altitude. Now we'll assess their suitability for X meridian observation Of course, we'll not be doing so for Equinox because since it's not suitable for site, so gauging its suitability for X meridian would not be of any value. So to get the to assess the suitability for X meridian observation, we need to get angle P. So for which we need to recall the value of SHA of the imaginary star on observer's meridian, which was obtained in the first question, and that value was 169 degrees 38.6 minutes.
So beta, this is the SHA of the star on the meridian. This is the SHA which we calculated in the first step beta, 169.38.6. Okay up to here?
Sir, on the left side, we also have SHA star 158.47.7.
That is the SHA of Spica beta. 158.47.7 is the SHA of Spica, and 169.38.6 which we have mentioned here is the SHA of our meridian.
Okay, sir. Okay, sir.
Okay, so we will find basically the difference between these two now.
Okay, sir. This just which we shown now, it is for calculated, and that SHA on the left side, which we taken from alumni.
Yes, that's right beta. Right.
Okay, sir.
So SHA of the imaginary star on meridian would be so much. SHA of the respective star is as tabulated here. The difference between these two for respective star shall give us the R angle P. So this R angle P for Spica is the difference between 169 degrees 38.6 minutes and 158 degrees 47.7 minutes. Likewise, we have got the R angle for all the stars.
Okay, have a look at this P angle now beta. Any doubts, let me know.
So there is no minus plus, it's just a difference only we have to write, right, sir?
That's right beta. No minus plus, only difference. Very good beta. Great. So you see beta, basically what we have done here is we have found out how much far away Spica is from our meridian. Spica is 10 degrees away because our meridian is at 169, Spica is at 158. The difference between them is 10 degrees 50.9. So Spica is 10 degrees 50.9 minutes away from my meridian. Elliot is only 3 degrees 4.5 minutes away. Mimosa is only 1 degree away. Cacrax is only 2 degrees away. So this is what we have found out.
Next we get is the time to Marpas or time from Marpas by dividing this R angle by 15 degrees 02.5 minutes. When we divide, we get time to or from Marpas as shown here. This is 43 minutes 16 seconds, and we have time for other stars also.
Okay. So you can check these timings beta. The time for Spica is 43 minutes 16 seconds. Any doubt in the times, let me know.
Sir, how did you get this time, sir?
Beta see, Spica is 10 degrees 50.9 minutes away from my meridian. And all the stars, they travel at a rate of 15 degrees 2.5 minutes per hour. So at a rate of 15 degrees 2.5 minutes, how much time will Spica take to come to my meridian? That's what I want. So what I do is just divide this time by 15 2.5 and you will get this 43.16. Try it out in the calculator.
Yes, sir. 10 degree.
Yes, sir, getting, sir.
Divided
Okay,
by
beta.
multiply by 60, then you will get in times.
Right, beta. So clear up to here, beta?
Yes, sir.
Okay, very good. So what we have obtained now.
One doubt,
Go
sir.
ahead.
One doubt, sir.
Go ahead.
Sorry to disturb, sir.
Go ahead.
Can you again, sir, explain this? How did this SHS star on meridian came, sir?
Okay, beta. You mean to say 169.38.6?
Yes, sir. Yes, sir.
Okay, just hold on. I will take the video a little back to show you how we
Sir,
get this
for
value.
Accurus का
Okay, just a minute. Let me first show you 169.38.6. I'm going back.
Thank you, sir.
This was type 1 beta. Okay. Look at left hand side bottom.
Understood, sir. Understood, sir. Thank you, sir.
Okay, all right. Let's go back. So here we are. The R angle is obtained. And from the R angle, we have now obtained the time also. So let's go to the time.
To Marpas or time from Marpas by dividing this R angle by 15 degrees 02.5 minutes. When we divide, we get time to or from Marpas as shown here. This is 43 minutes 16 seconds, and we have time for other stars also.
Any more doubts up to here?
Yes.
Okay, very good, beta. Now try to understand what we have obtained. What is this 43 minutes? This 43 minutes is basically how far Spica is from my meridian. Spica is going to take 43 minutes to come on my meridian. Elliot is going to take 12 minutes to come on my meridian. Or you can say Elliot is 12 minutes away from my meridian. Spica is 43 minutes away from my meridian. Mimosa is 5 minutes away and Gacrux is 10 minutes away from my meridian. Right, beta?
Yes, sir.
Very good.
Now we use nautical tables and get the X meridian limits using the nautical tables. We have used the Norris tables to get the X meridian limits. So these X meridian limits are as per the Norris table: 29 minutes for Spica, 44 minutes for Elliot, and the others as listed.
Okay, beta. Now these limits are picked up from the X meridian tables. If you want, you can go to the tables and check these values. We first go into table 1. We get the factor A from there. With factor A, we go to table 4. Table 4 gives us the limit. So these are the limits picked up from the tables. Any doubt in these limits?
Just a minute, sir. He's checking the tables.
Yeah, please do, beta. I'll wait.
I'm getting from the table 1 with cross reference of latitude and declination, getting 11.6.
Okay. Go to table 4 with this.
Yes, sir. Table 4. And factor A, it's 11.6 between 15 and 20. So that factor A, I should be looking in the table 4 side.
That's right, beta.
So factor A got 11.6. Here I have factor A 20 and 15 in between. So that is between 8 and 10.
No, there is some mistake somewhere, beta. See, for Spica, you are looking for Spica, right?
Yes, sir.
Okay. Now the declination of Spica is 11 south. The latitude is 20 north. Check the table 1, beta. Lat and dec are opposite names. Check you went into opposite name part.
Latitude and declination.
It's written on top of the page. Lat and dec same name. Then you have lat and dec opposite name. Go to lat and dec opposite names. Huh?
Okay, so I have checked in the same name. A different name, 20 north, 11 degree, 3.52.
Very good. Now come to table 4.
Yes, sir. 3.52 is between 29 and 32 minutes interval.
So if you interpolate, you will get it 29. Round it off to the nearest minute.
Okay, sir.
Okay, great. Shall we move ahead?
So whatever we get the value, we'll put it here and we'll say this is the X meridian limits.
That's right, beta. The meaning of this limit is that if spica is up to 29 minutes away from us, we can use it for X meridian. If it is more than that, we cannot use it.
So earlier we discussed this 43 minutes 16 seconds is from observer's meridian, right?
Yes, how far away spica is from our meridian? Spica is 43 minutes away.
From
And
observer's
now we
meridian.
have checked what is the limit for spica. The limit for spica is 29 minutes. So is it suitable? Let's see.
We compare these X meridians limits obtained from nautical tables with the time to or from Marpas that is calculated. And what do we find? Except for Spica, which is outside the X meridian limits, the other three stars, Elliot, Mimosa, and Gekrux, they all are within the X meridian limits, and therefore these three stars are suitable for X meridian observation.
So
Okay, beta.
I'm not getting how it is getting suitability.
Okay, beta. Try to understand. I'll explain you.
Yes, sir.
Spica's X meridian limit is 29 minutes. What does that mean? It means that if spica is within 29 minutes of our meridian,
Yes,
east
sir.
or west, if it is within 29 minutes of our meridian, you can use it for a X meridian site. If it
Okay,
is
sir.
more than 29 minutes away, it has gone too far off, it cannot be used for X meridian.
Okay, sir.
And now we check that right now spica is 43 minutes away from us.
Yes, sir. So not
So
suitable.
that's correct. So it is not within the limit, that's why not suitable. All other are within the limit. Elliot is only 12 minutes away. Its limit is 44, so it is within the limit. Mimosa is 5 minutes away, its limit is 61, so suitable. Gakrux is 10 minutes away, and the limit is 60 minutes. Again, it is suitable.
Okay, sir. Understood, sir. Thank you, sir.
Okay, beta. Great.
Now, in some questions, if the R angle, like in this case, it was given to find the stars which are within 15 degrees of observer's meridian. Now, if this angle, R angle limit is not given in the question, then, and we have to perform this check for X meridian observation, then we can check the stars falling within 20 degrees of R angle from observer's meridian. So if this limit is not contained in the question, you can set this limit at 20 degrees and carry out a check that shall suffice our purpose.
So, is the doubt cleared now, beta? You are asking if R angle is not given, what is to be done?
Yes, sir. Yes, sir. Understood.
Very good, beta. Great, beta. Clear? Any doubts? All right. Very good. So let's take a break here, beta. Let's take a break. Let's close down for the moment. Okay, let's take a short 5 minutes break, get refreshed, and come back. Last two types we will do then. 5 minutes, huh? Okay, beta, are we back?
Yes, sir.
Okay, good. So let's move on to the next two types of question. Now, beta, up to here, the questions were moving in the same pattern. We had the first question, find the stars within a certain hour angle, then which of them are visible, which of them are suitable, which of them are suitable for X meridian, all moving on the same track. Now, these last two types which we have are slightly different. Okay, so the wording is slightly different. The question is also different. So let's see these two types. Let's go.
Now, there may be situations or questions in which we may have to find stars and planets which cross observer's meridian within a given interval of time. For example, this one, in position 40 degrees 10 minutes north, 121 degrees 15 minutes east, find the stars and planets of second magnitude and brighter crossing observer's meridian between 1800 hours to 1900 hours ship's time, zone time minus 0800 hours on 21st September 1992. To handle such questions, we need to obtain the SHA of an imaginary star on the observer's meridian, both at the beginning of the given interval and at the end of the given interval. So we get two SHA values of this imaginary star. One when it is on the observer's meridian at the commencement of the interval, and second when it is on the observer's meridian at the end of the interval. We know how to calculate the SHA of imaginary star on the observer's meridian. We can equate the LHA of that imaginary star to 360, and this LHA is equal to LHA Aries plus SHA of the imaginary star. We have already calculated in the first question, and we can repeat that process out here. If the duration of time is not given in the question and it is only AM or PM twilight, then for AM cases, the interval used is between the starting time of the nautical twilight to the starting time of the civil twilight. So that shall become the interval. Commencement of the interval shall be at the onset of nautical twilight, and the ending of the interval shall be at the start or onset of the civil twilight. For PM cases, this interval shall be between end of civil twilight to the end of nautical twilight. We can identify the stars and planets within the SHA range thus obtained, corresponding to the magnitude of stars and planets that is given in the question. Now, all the stars within this range shall be crossing the observer's meridian during the given interval. Whether they shall be visible or not, or whether they shall be suitable for taking sight or not, or whether they shall be suitable for X meridian observation or not, we know once we get a comprehensive list of all the stars and planets, we can do the further analysis depending on whatever may be expected of us in that particular situation or particular question.
So we will be using these steps now, beta, one by one to find out the stars.
So now we're in a position where we can solve this question. In position 40 degrees 10 minutes north, 121 degrees 15 minutes east, find the stars and planets of second magnitude and brighter crossing the observer's meridian between 1800 hours to 1900 hours shift mean time, zone time -8 on 21st September 1992. So we first find out the GMT at the commencement of the required interval and GMT at the end of the required interval. So the starting time, ship's mean time is 21st day, 18 hours. Zone time, -8. And we get GMT, longitude is GMT least, 21, 10, 0, 0, 0, 0. So we get the GMT at the commencement of the interval. Likewise, we calculate the GMT at the end of the interval, 21, 19, 0, 0. Zone time -8, and we get GMT as 21 day, 11 hours, 0, 0 minutes, 0, 0 seconds.
Any doubts up to here, beta? Great.
Now we get the LHA Aries for these two GMTs. So at the starting time, GHA Aries for 21 hours, 21 day, 10 hours is so much. Increment is 0 because it is 0 minutes, 0 second. We get GHA Aries as 150 degrees, 31.9 minutes. We apply observer's longitude to it. Longitude east, GHA least, we add the longitude, and we get the LHA at the commencement of the required interval as 271 degrees 46.9 minutes. That is the LHA Aries at the commencement of the interval. We get the LHA Aries at the end of the interval. You can see the values coming up on the slide. You can also check them from your almanac. And we get the LHA Aries at the end of the interval.
Any doubts up to here, beta?
Now we find out the SHA of the imaginary star on the observer's meridian at the starting of the interval and at the time of the ending of the interval. So for imaginary star on the observer's meridian at the commencement of the interval, LHA star, which is equal to 360 degrees, will be equal to LHA Aries of 271 degrees 46.9 minutes plus SHA star, which gives us the value of SHA star to be 088 degrees 13.1 minutes at the commencement of the required interval. Exactly the same way, we can get the SHA of the imaginary star on the observer's meridian at the end of the interval. And we get this value to be 73 degrees 10.6 minutes.
So now you see, beta.
So one doubt, sir.
Go ahead, beta. Go ahead.
Sir, here zone time is given 0800. But if I take here a LIT, it is coming 0805 minutes. That is 8 hours, 5 minutes.
Okay, beta. Beta, LIT is
So-
applied to local mean time, LMT, to convert it into GMT. Now what they have given here is ship's time. So ship's time and GMT difference will not be LIT, it will be the zone which you are keeping on the ship.
Okay, sir.
Okay. So if in the same question they had told 1800 to 1900 LMT, they will not give the zone time then we will use the LIT.
Okay, sir. Thank you. Understood.
Okay. Great, beta. Now you see, beta, in the previous question, we were given only one time. So we were calculating one SHA and then we were adding or subtracting the R angle to get a range. Now the only difference in this question is that they have given us 2 times. For these 2 times, we get the 2 SHA and the range is automatically obtained. Rest of the question is exactly similar. We have the SHA range now from 073 to 088. We will go to the table and find out the stars within this range, exactly same as before. So this is the only difference in these questions.
We have got the SHA of the imaginary star on the observer's meridian at the commencement of the interval and at the end of the interval. So all our stars and planets of interest should have the SHA in this range. So the SHA range that is of interest to us is from 073 degrees 10.6 minutes to 088 degrees 13.1 minutes. We go to the star tables and we find out stars of second magnitude and brighter in this SHA range. And for planets, we'll go to the daily pages of the Nautical Almanac for 21st September. Stars and planets of second magnitude and brighter crossing given observer's meridian between SMT 18 to 19 on 21st September. The stars will be only two. You can check. We already have learned this, how to figure out these stars in the star tables in the range of SHA. And the stars are Vega and Cos Australis. These are the two stars in this SHA range meeting this magnitude requirement as per the question. And when we go to the daily pages of the Nautical Almanac for 21st September 1992, we find there are no planets with SHA in the given range on that day. Therefore, we do not have any planet which is going to cross the observer's meridian in this window. On the other hand, we have two stars of magnitudes of second magnitude and brighter, which shall cross this meridian of the observer between 1800 hours to 1900 hours.
Have a good look, beta, and let me know any doubts coming anywhere.
Sir, so whenever the time range is given, then we have to follow this procedure.
Yes, beta.
If a specific time is given, then our angle will be given.
Yes, that's correct, beta. You are right.
Yes.
Very good, beta. Great. Let's move ahead then.
Now, we have already calculated the stars, whether they are going to be visible or not, whether they are going to be suitable for sight or not, or whether they are going to be suitable for X meridian limits or method or not. I think we have to execute the respective step further if we have to assess them for any other parameter which we have learned, be it their visibility, be it suitability for sight in general, or be it their suitability for X meridian observation. Having found the stars and planets which shall cross the observer's meridian within a given interval.
Any doubts, beta?
Yes, sir. Sir, previously the stars Vega is 0.1 magnitude, but in question they're asking a second magnitude. Second magnitude is 1.0 to 2.0, correct, sir?
Okay, beta. Now look carefully, beta. They are asking second magnitude and brighter. So this will include second magnitude, also the first magnitude, because first magnitude is brighter than the second magnitude, na?
Okay, sir. Okay, understood.
Okay.
And brighter.
If and brighter was not mentioned here, then we will not pick up Vega here. We will only pick Cos Australis.
Okay, sir.
Okay, good.
Or X meridian observation. Having found the stars and planets which shall cross the observer's meridian within a given interval, we could similarly be required to find the stars and planets that shall cross the observer's inferior meridian during the given interval. Observer's inferior meridian is the meridian which is 180 degree opposite to the observer's own meridian. Say, for example, this question. In position 40 degrees 10 minutes north, 121 degrees 15 minutes east, find the stars and planets of second magnitude and brighter crossing the observer's inferior meridian between 1800 hours to 1900 hours ship's time, zone time -8 hours on 21st September 1992. Now, for such cases, we'll have to obtain the SHA of an imaginary star, which is on the observer's inferior meridian this time. Not on observer's meridian, but on observer's inferior meridian, when at the commencement of the interval and at the end of the interval. For imaginary star on observer's inferior meridian, the LHA, because the imaginary star is on the observer's inferior meridian, so the LHA of the star in this case shall not be 360, but it shall be 180. So the difference lies here. In the earlier case, to find the SHA of the imaginary star, we were equating LHA to 360 degrees. In this case, because the imaginary star is not on the observer's meridian, but on the observer's inferior meridian, so the LHA of the imaginary star shall be equated to 180 degrees. If the duration, like the previous case, is not mentioned in the question, then for AM, the interval shall be between the start of the nautical twilight to the start of civil twilight. And for PM, it shall be the end of the civil twilight to end of the nautical twilight, which has been explained earlier. Identify stars and planets of the required magnitude within the SHA range, thus obtained like the previous case. All stars having SHA within this range will be crossing the observer's inferior meridian during this period. It does not mean that they need to be visible. It does not mean they'll be suitable for sight. But yes, what they would be doing is they would be crossing the observer's inferior meridian. Now, here comes an important change. Out of these stars, only those which are circumpolar will be visible to the observer. Because when the celestial bodies cross the observer's inferior meridian, then they shall be above the observer's rational horizon only if they are circumpolar. Otherwise, they will be below the horizon. So only those stars and planets which happen to be circumpolar shall be visible if we have to ascertain the visibility issue. A star will be circumpolar only if latitude and declination are same names, and at the same time, that is plus, the sum of latitude and declination is greater than or equal to 90.
Clear, beta? Any doubts? Very good.
So out of the stars that you list, only those would be visible which are circumpolar. Now let's solve this question. In position 40 degrees 10 minutes north, 121 degrees 15 minutes east, find the stars and planets of second magnitude and brighter crossing observer's inferior meridian between 18 to 1900 hours SMT, zone time -8 hours on 21st September 1992. So first we get the GMT at the commencement of the interval, and you can see the SMT 21 day 18 hours, zone time -8, GMT 21st day 10 hours, and we get GMT at the commencement of the interval. We get the GMT at the end of the interval, which comes to 21 day 11 hours 00 minutes 00 second. Now we get LHA Aries for both these GMTs. GHA Aries at commencement time is 150 degrees 31.9 minutes. We apply the longitude. Longitude is the GMT and we get LHA as 271 degrees 46.9 at the commencement of the interval. Likewise, we get LHA Aries at the end of the interval. You can see it on your screens, and LHA Aries comes to 286 degrees 49.4 minutes. Now we get the SHA of an imaginary star on observer's inferior meridian at the commencement of the interval and at the end of the interval, and same is obtained by equating the LHA of the imaginary star to 180. You can see here LHA of the imaginary star is equal to 180, LHA Aries is 271, and putting these values, we get the SHA of the star as 268 degrees 13.1 minutes. Likewise, we get the SHA of imaginary star on the observer's inferior meridian at the end of the interval, and we put the values, and we get the value of the SHA as 253 degrees 10.6 minutes.
Any doubts up to here, beta?
So suppose in a question, if they ask for superior meridian, then it is observer meridian, correct, sir?
Ask again, beta. I didn't get you.
Sir, if it is given inferior meridian, so we are taking 180 degree. What
Yeah,
if they
that's
ask?
right.
Yes, sir. If they ask for superior meridian, then it is observer meridian itself.
Okay. Usually we do not call it as superior meridian. We call it observer's meridian and observer's inferior meridian.
Okay, sir. Observer's inferior meridian is inferior meridian, and observer
That's-
meridian is same meridian as observer.
Yes, that's right. That's right.
Okay, sir.
Now we have obtained the range of SHA in which we have to find the stars and planets of the required magnitude. The SHA range of interest to us is from 253 degrees 10.6 minutes to 268 degrees 13.1 minutes. We go to the star tables, look for stars in this range with magnitude of 2 and brighter, and we get the following stars. We get Adhara, we get Sirius, we get Elena, we get Canopus, we get Mirzam. So these are the 5 stars that we get, which have the SHAs. You can see they are in this range, and their magnitude you can see here. They are of magnitude 2 and brighter. So these are the stars which shall cross the observer's meridian between 1800 hours to 1900 hours ship time on 21st September for an observer in position 40 degrees 10 minutes north, 121 degrees 15 minutes east. Now we go to the daily pages of the Nautical Almanac for 21st September to see if any of the planets fall in this range of SHA. And we find that Mars has a SHA of 264 degrees 06.2 minutes, which is in this range. So Mars would also be crossing the observer's inferior meridian in the given window. Now, where do we get this SHA of Mars from? Where do we get the declination of Mars from?
Okay. That we are aware, we get it from the daily page of the almanac. So have a good look at the solution, beta. Let me know any doubts coming in.
Yes, sir. As per the condition, latitude and declination should be same name. So here only the Alhena is applicable, correct, sir?
Yeah, if they wanted to find out which of them will be visible to us, then in that case, our latitude is north, so only Alhena will be visible to us.
Alhena and Mars. Yes, sir.
Yeah, that's right. Declination of Mars is also north. Alhena and Mars. Now you have to check the second criteria also, beta. That is L plus T should be greater than equal to 90. So latitude is 40. Alhena is 16. So that totals up to 56. So not visible. And for Mars also 40 plus 23, that comes to 63. So they will cross, but they will not be circumpolar because L difference D is not greater than 90.
Okay, sir. So both the conditions should meet.
Yes, both should meet.
Okay, sir.
सर ये प्लैनेट का मैग्नीट्यूड कहाँ से मिला सर?
बेटा go to this date 21st September 92 पे चले जाओ, almanac open करो.
21st September. Yes, sir.
You have the Mars column there. Mars के नाम के साथ आगे देखो क्या लिखा बेटा. You have a number?
Plus 0.4. Okay, sir.
Yes, that is the magnitude.
And sir, this negative magnitude of stars,
right?
That the first magnitude is from 0 to 1.
No. First magnitude is anything equal to and less than 1.0. The negative ones are also included in first magnitude, beta.
Okay, sir. Okay. All negatives are coming under first magnitude.
That's right.
Right, sir. Right.
Sir, actually for
Sir,
the observer's meridian, there is
sir,
only one condition. which
One
is,
by one, beta.
for the observer's meridian, there is only one condition: latitude minus declination should be less than 90. But for the inferior, we have two conditions: latitude and declination should be same name, and also it should be greater than 90.
Yes, that's right, beta. That's right.
Okay, sir.
Next out, beta.
ठीक है सर वो मैग्नीट्यूड के लिए ऊपर देख मिल गया सर मार्स का मैग्नीट्यूड
Okay. Okay, beta. Great. So I'm closing down the presentation now. Okay, beta. Now I'll be sending you a note which will include all the things which we discussed in the video. So all the steps will be mentioned there, all these 5 types, how the questions are to be solved. And then I'll be giving you one assignment. So you will have the questions. So practice these questions, beta. These are little tricky questions. So go slow, step by step, and practice all of them. Okay.
Yes, sir. Sir, in the PL assignment solution number 6, sir, in the last part I have doubt, which I am getting D long is 0 degree 51.7, but in the solution is mentioned 0.9.
0 degree 51.7. Solution,
Yes,
it is mentioned 0.9. So
yes,
that must be 0.9 degrees, beta. They rounded off to degrees.
yes, sir. So,
Sir, in solution set is given 0.9 minutes, but
yes,
it
sir.
should be
0.
0.9 degree.
Actually, it is
Okay.
0.9.
Okay.
Uh,
That error can be there. No issues. So both of you are getting 0.9 degrees, huh?
yes, sir.
Okay. That error can be there, beta. That's perfectly all right. It can be there. I'll correct it.
Okay, sir.
Let me
Yes,
have
sir.
a
Just
look also.
so, am I correcting? Am I doing correctly, or just want to confirm, sir?
Okay. Give me a minute. Just a minute. Which question is that, beta?
6, sir.
Number 6. Okay, just a minute.
Yes, sir. This is D
This
long
one,
now.
beta.
Yes, sir. This is 0.9 degree, which I'm
Okay.
the calculator.
Okay, beta. All right. All right.
So the final
D long.
longitude I'm getting 161 degree 31.6.
Okay. Okay. What about other people, beta? Are you getting the same difference?
Sir, he is asking that it is 0.9 minutes or 0.9 degree to confirm. So that can
Okay,
be
just a minute.
clear.
Yes, sir. That is my doubt. Actually, I'm getting 0.86 degree.
Sir, it is 0.9 minutes only.
It should be 0.9 minutes, beta. I have just put it in the calculator. It's coming as 0.86 minutes. You see, this is 0.6 minutes here, beta.
Okay, sir. The departure is in minutes.
Yeah, that's right. I just punched the numbers in the calculator. It's coming to 0.8622 minutes. So rounded off, it'll be 0.9 minutes only.
Okay, sir. So this 0.6 I'm taking from the gap that is in nautical miles. Whatever we are getting is in minutes.
Yeah, that's right, beta. Whatever you are getting here is in minutes.
Okay, sir. Okay, sir.
1 minute is equal to 1 nautical mile.
1 minute. Okay, sir. Thank you, sir. Thank you, sir.
Okay. So this must be 0.6 centimeters.
Yes, sir. 0.6.
Right. So that's 0.6 minutes. And this is 0.9 minutes.
Okay, sir. Thank you, sir.
Okay. Good. I checked. Okay, beta. All right. So let's close this.